In this training, we will provide an overview of the MotionMonitor xGen software with a focus on the analysis functionalities. You may follow along on your own device, just be aware that certain aspects of the software may look a little different on your computer. We ask that you make note of any questions that may arise and ask one of our client support engineers during your lab's personalized system training. First, we will navigate to the TMM xGen icon on the desktop and double-click to open. The first window that appears is where you will select the user ID. This can be organized for various users, projects, classes, or whatever will make the most sense for your lab. On each installation of the software, there is a user labeled Sample Scholastic Files. This is a resource for you that contains various sample activities and analysis components. We encourage you to take time to look through these activities and familiarize yourself with the variety of analysis capabilities in the software. These users are saved within the Program Data folder, but if desired, you may browse to a different location on your computer, such as a server. We will be using the Sample Scholastic Files User today, so you may follow along on your own device. The first window that opens after selecting a user is called the Live window. This is where you will set up or load a workspace prior to data collection. Workspaces are saved templates in the software that include settings such as hardware, subjects, icons, and analysis settings. You can load saved workspaces from the Open Workspace icon or the File menu Open Workspace. You have a couple options for saving workspaces: Save Workspace and Save Workspace As. Clicking Save Workspace will save a workspace called Current. This is the workspace that will open in the Live window when opening the software and is saved anytime you close the software or after completion of a subject setup. Clicking Save Workspace As will prompt you to save a named workspace. It is best practice to load and save a named workspace for data collection or for batch processing, especially if there are multiple projects within a single user. This prevents inconsistencies, and if saved in a deactivated state, will set the icons appropriately and should make for a smoother, repeatable, and more consistent data collection or analysis processes. In the workspace, we have an animation window and components window. The components window is where you will control the components of the software, and it contains a setup and analysis tab. Within the setup tab, you can set up your project with hardware, subjects, and permanent variables and scripts. Within the analysis tab, you can control what you see in the animation and graphs, as well as define variables and generate reports. I will cover both of these components window tabs, starting with the Setup tab. In the Hardware node, you can add or update hardware. To add hardware, you can right-click and add the desired hardware. This will look a little different as you follow along on your device, because my screen will show all the different types of hardware we integrate with, while yours will only show the specific hardware you are currently licensed for. As you can see, we support a number of various hardware types, including cameras such as webcams, marker-based, and markerless cameras, EMG, IMUs, EEGs, microphones, force plates, eye trackers, and virtual reality. Here you can set up the subject, add permanent objects, and define any permanent variables. With the permanent script variables, scripts, and toolbars, you may use those to control icon functionalities or to initiate program flows. This helps facilitate efficient, consistent data collections. Now we will walk through an example activity that was previously recorded and available in the Sample Scholastic Files User. To open an activity, you can use the built-in icon here, or you can navigate to the File menu, Open Activity. Here you can see the sample activities available to you within the Sample Scholastic Files User. We have a variety of examples including baseball, bike riding, jumping, ergonomics, gait, reach, and a Y balance test. Again, we would encourage you to take some time to look through these activities and the range of variables defined in each of them. Today, we will be using the Gait Walk 1 activity. In the animation window on the left, we have a half-body representation of the subject walking through the space over two force plates. Notice how you can see the force vector on the force plate as they walk over it. This activity was created using individual markers, as you can see on the subject here. We also support a range of ways to track segments, including clusters, inertial sensors, and data derived from markerless AI models. Once you've gotten past building the subject model, subsequent steps in the analysis will be the same, independent from the hardware used for collection. On the right, we have various examples of data displayed in graphs. There are graphs that show kinematics like knee flexion, ground reaction forces, EMG, booleans defining stance, heel strike, and toe off, as well as some kinetics graphs such as ankle moments. Within each of these graphs, you have the ability to zoom and translate the data. To zoom in on the x-axis, you can use your scroll wheel. To zoom in on the y-axis, left-click and scroll. To translate, left-click and drag. You also have the ability to scale to fit directly on the graph by right-clicking on the graph of interest and selecting Scale to Fit. This function is also available from the Graph node in the Components window. Similar to the display controls in graphs, you also have the ability to change the animation view. To zoom in the animation, you can use your scroll wheel. To rotate the animation, left-click and drag. To translate the animation, right-click and drag. Besides the controls within each of these windows, you may choose how you would like the entire layout of the software to look. You can easily change the sizing of the windows by hovering over the edge of the window, left-click and drag the window to make it bigger or smaller. To move windows around, you can left-click the title and drag. You can drop the window wherever it highlights blue. You may also undock windows to a second screen if you would like participants to interact with a live data graph or view the animation. You can stack multiple graphs on top of one another by picking up a graph hovering it above the graph you would like to stack, and dropping. The graphs are now tabbed at the bottom. If you would like to hide a window, you can simply click the X in the top right corner of any window. This does not permanently delete the window, it just hides it from the active window layout. If you accidentally exit out of a window or simply cannot find a window of interest, you can easily bring it back into view by navigating to the View menu and selecting the window name. As you become more comfortable with the MotionMonitor xGen, you can take advantage of our advanced functionalities, such as creating or customizing icons that control the window layout and which graphs are shown at a time. You may already have some of these icons defined in your data collection workspace. Now we will take a look at the hardware used in this activity within the Setup tab of the Components window. Within the Hardware node, you can see the hardware that was used to create this activity. This Gait activity was created with Vicon cameras, 2 measurement computing boards, and 2 force plates. Within the Hardware node, you also have the ability to apply repairs and filters. These filter settings can easily be accessed within any marker, sensor, or channel node. For example, if we expand the Vicon node and click on a marker, the filter settings will appear in the Parameters panel at the bottom. Within this panel, you have the ability to add a gap repair, a Butterworth, Chebyshev, and a low-pass or high-pass filter. You can apply these filters to one marker or easily apply them to all markers by clicking Apply to All. Next, we will take a look at the subject for this activity. Within the Subject node, you can see where the model is built by accessing the segments and joint definitions. The joints that appear within the Joints node are dependent on the segments that are selected and defined. For example, in this activity, only the lower extremity segments were selected, so only the lower extremity joints are available. The orientation of the axes of the default segments may be customized. Landmarks and custom axes may also be defined in advance of data collection. Anthropometrics can also be edited here. Now we will move on to the Analysis tab of the Components window. This is where you can control what you see in your graphs or animations and export your data. First, we will take a look at the types of graphs supported by the MotionMonitor xGen. Under the Graphs node, you can add time series graphs like kinematics, kinetics, and ground reaction forces. Frequency domain graphs can be used to graph noise levels of sensors, markers, or channels. XY graphs can be used to show interaction between two scalar variables, such as angle-to-angle graphs, or to visualize center of pressure data from force plates. Bar graphs are helpful for presenting data more intuitively. They could be used as a form of feedback to show interlimb differences or to encourage a participant effort, such as meeting a threshold. The Animations node controls everything you see in the animation window. Let's take a look at the animation window and what we have available in the Animations node. Within the Animation node, you can toggle items on or off, such as the force plates, world axes, or the grid. You can also add text and traces in the animation. More detailed examples of these will be shown later. Next, we will move on to analysis variables. Variables can be created on both the Setup tab as permanent variables, as well as the Analysis tab as analysis variables. Permanent variables are variables that are known at the time the activity was collected and cannot be changed after the collection is completed. An example of a permanent variable might be the subject's height or weight. Analysis variables are variables that can be created before or after data collection and take their value in the present. If a change is made to an analysis variable, anything dependent on that variable will be updated to reflect that change. We will go through some examples of analysis variables soon. For both permanent and analysis variables, a variable type can be selected. Boolean types can take true, false, or invalid values. Integer types are whole numbers. Scalar types are real numbers. Vector types represent a 3D position in space and possess a magnitude and direction. Vector types can be characterized by an x, y, and z scalar value. Rotation types are measures of orientation and can take the form of Euler angles, quaternions, or cosine matrices. Axes types are values with a representation of position and orientation. Time types are timestamps that return time in seconds when used in a calculation. String types are groupings of alphanumeric characters. Color types can be defined to dynamically control the color for elements visualized in the animation window. Variable groups can be added to organize variables. Let's look at an example with one of the variables already defined in this activity. Here we will look at right knee flexion. For variables, you can select the variable type, enter the name, and define the expression. If you update the name at any time, it will propagate throughout the software, except in scripts, which are to be updated manually. For the expression, you can choose Use Drop Lists or Use Formula. Here, Use Drop Lists was selected. For drop lists, as you pick an option on the left, different options will become available as you go right. In this example, Subject 1 was selected first, then Segments, Right Shank, Angles, and Flexion. If we choose Use Formula instead, we can see how the expression changes. Now, instead of multiple drop lists, we have one continuous formula in the expression field. We still have the same elements from the previous option with Subject 1, Segments, Right Shank, Angles, and Flexion. To get this formula definition, you can right-click and insert variables. If the syntax is wrong or incomplete, the text will show up as red, and if it's a valid expression, the text will be black. Now let's walk through an example of creating a new variable. Since we looked at right knee flexion already, let's create max right knee flexion for our new variable. To add a new variable, right-click on Analysis Variables and choose Add Scalar Variable. New variables will appear at the bottom of the variable list, and scalar variables will appear as x1, x2, and so on. Max right knee flexion is a scalar type, but you can still change the type even after adding the variable. We will change the name to max right knee flexion. When you leave spaces in the variable name and click away, it will automatically remove the spaces. For the expression, we will use a formula. Right-click in the formula field and you can see the options for Insert Variable or Insert Operator. In the previous example, we clicked Insert Variable to add our variable. Since we are defining a max right knee flexion, we will first need to add the max operator. Here you can see the same variable types we looked at previously, but now they represent operator types. Operators help with everything from simple to complex calculations within variables or scripts. Boolean operators include true and false values, as well as if statements, which we will be using in an example later. Integer and scalar operators contain many of our mathematical functions like trigonometry, minimums, and maximums. With vectors, you can define vector expressions and calculate dot product or cross product. Rotation operators allow you to define rotation expressions and use them in calculations. Axes operators allow you to define axes expressions and perform transformations with them. You can create timestamps or events with time operators. You can define strings of text with string operators. And with color operators, you can define a color expression with its RGB values. We will go over an example with this one later. We can find the max operator in the scalar operators. Within each operator, it specifies what the formula needs to be a valid expression. For the max operator, it needs x, which is a scalar variable, a start time and stop time for when it is searching for the max value, and an interval, or how often it is searching for the max value. Click on the operator to bring it into the variable expression field. Now the operator is in our expression field with the exact number of empty fields needed to be fulfilled. In the first field, we need a scalar variable, which in this example is right knee flexion. To add a scalar variable, right-click in this first field and navigate to Insert Variable. We can either completely redefine right knee flexion by starting with subject 1, then segments, and so on. Or, since we already have it defined under analysis variables, we can simply select right knee flexion from the list. Next, we need a start time for our max operator. In this example, we will have our max operator calculate the max over the whole trial. In the second field of this operator, right-click and navigate to Insert Variable. The MotionMonitor xGen has some built-in variables available for us, including the initial time variable. This variable represents the very beginning of the trial. You will notice that we have a few options within this initial time. If we select time at the top, that will include all parts of time that are listed below. To bring initial time into the variable expression field, click on Time at the top. Next, we need a stop time for our max operator. In the third field of this operator, right-click and navigate to Insert Variable. Just as initial time is a built-in variable, final time is a built-in variable to represent the very end of a trial. Once again, to include all parts below, select Time at the top. Finally, we need to specify the interval. A cubic spline is applied to the data so there is flexibility to use any interval, but if you wish to avoid downsampling or upsampling, we can simply use the reciprocal of the measurement rate of the hardware. To find the measurement rate, navigate back to the Setup tab and the hardware used to capture the subject. In this case, Vicon cameras were used. In the parameters panel below, we can see the measurement rate specified as 60. So, in the last field of this operator, we can type in 1/60. Like I previously mentioned, the text in this field will appear black if it is a valid expression and red if it is an invalid expression. For example, let's say I typed in this operator and accidentally misspelled initial time. Now the text is red, meaning there is a mistake somewhere. The software will actually give you a hint about what is wrong if you hover the mouse over the red text. It tells us that initial Tim is not a recognized time expression. That alerts me to go check my definition, see my mistake, and fix the problem. If I add the E back into this expression and click away from the field, the text turns back to black, meaning it is a valid expression. Now this max variable is completely defined. Now that we have our analysis variable defined, there are a few ways to add it to a graph for visualization. To add an analysis variable to its own graph, you can either right-click on the name of the analysis variable and click Graph, or click on the name of an analysis variable, then click Graph in the Parameters panel below. You can see that a graph titled Max Right Knee Flexion has appeared on the right. To bring the plot into view, you can zoom out or simply right-click and scale to fit. You might want to keep your workspace a bit tidier and have multiple plots within one graph, so you can easily right-click on the analysis variable and click Copy, then scroll up to the graph of interest and paste. Notice on the right how the max right knee flexion variable is now visible in the existing graph as the yellow plot. To add a new graph, right-click on the Graphs node and click Add Graph. The new graph will appear at the bottom of the graphs list, in this case as graph 10. If you click on the name of the graph, its parameters panel will appear in the panel at the bottom, and you can edit the name of the graph. We will change the name to Max Right Knee Flexion. To add a plot, right-click on the graph name and click Add Plot. For the plot function, you could redefine your variable here, or if the variable was already defined under Analysis Variables, you can simply select it through the drop lists. In our graph on the right, we can once again use the Scale to Fit function to bring the graph into view, either by right-clicking on the graph itself or by right-clicking on the graph in the Components window. Back in the Plots Parameters panel, you can change the color of the plot, you can also update the plot type from continuous to discrete to display data at the sampling interval rate. This is easier to see when zoomed in on the graph. You can update the sampling interval of the graph within the Graphs Parameters panel. Notice how the discrete plot changes in the graph as I update the sampling interval. Similar to how we were able to add a graph from an analysis variable, we can also add an analysis variable from the graph's plot. As I mentioned before, we will now walk through an example using a bar graph. So first, we will go ahead and right-click and add a new bar graph. To add bars to this graph, you can right-click on the name of the graph and add a bar. Or, click the Add Bar button within the Parameters panel. Bar graphs are an intuitive tool for providing visual feedback to participants to encourage certain behaviors, or may be used by researchers to quality check effort or indicate level of risk. You might set a threshold for a targeted amount of movement or force, or EMG magnitude, for example. In keeping with our knee angle metrics, we will define one of the bars as right knee flexion. This bar's value will change over the course of the trial, and the other bar as the target threshold. This value will stay constant. We will rename the first bar right knee flexion, and define the function with our previously defined analysis variable. Notice how the bar appears on the graph to the right and changes as the activity plays back. Now let's define the threshold bar. And we will switch the function from use drop list to use formula. Now we can simply type in an arbitrary number for the threshold, like 50. Notice how the threshold bar appears on the right. To bring the threshold bar closer to the flexion bar, we can update the position to be the same as the flexion bar. This allows us to see how close the subject is to meeting the threshold value. Within bar graphs, the MotionMonitor xGen also supports the ability to overlay bars on top of each other by checking Allow Overlay. Lastly, we just need to change the opacity of the threshold bar so that we can see both bars. We will change the opacity to 0.5. Now, our bar graph displays the flexion value as if we are filling the bar behind it. You can also adjust the width of the bar and if the graph displays vertically or horizontally. Next, I will walk through an example similar to the bar graph example, but in this example, meeting the threshold value changes the color of the subject's bones. First, I will move the animation window to the side so that we can see it at the same time as the components window. Now we will go into the Animations node and expand Subject 1. Here, we can toggle on or off segments in the animation. In the Parameters panel below, we can change the opacity and the color. Now you can see that the right thigh stays orange throughout the entire activity. We can utilize this function even further by having the right thigh turn orange only when a specific threshold is met. We can achieve this by using the color operator. Instead of using the color picker for the color, we will change to use formula. Now the orange we had picked is written in a formula with its RGB values. We can now use an if operator to determine when the bone will change color. In the formula field, right-click and insert operator. We will navigate to the Boolean operators to find our if operator. Next to the if operator specifies exactly what is needed to be a valid expression. In this case, it needs a Boolean variable b, a value if true, and a value if false. We can now click this if operator to bring it into the expression field. We can once again use right knee flexion as our Boolean variable, but we will need to add a qualifier to make it into a Boolean expression. We will right-click in the first field, insert variable, and select the right knee flexion variable. Now we can use the threshold like before and say greater than 50. Giving us a complete Boolean expression. Next, we need to add a value if this Boolean expression is true, and we will use orange as this value. Since we have already have the RGB values for orange on the left, we can simply copy and paste it into our expression. Lastly, we need the color value if the Boolean expression is false. In this case, we will choose to keep it white. In the last field, right-click and Insert Operator, navigate to the color operators, and click the color operator. This operator needs a value from 0 to 1 for each of the red, green, and blue variables. For white, we will enter a 1 in each of these spaces. If we click away from the text, it turns black, meaning it is a valid expression. Now, let's watch as the subject's right thigh turns orange when it surpasses the set threshold. As I mentioned earlier, you can also add text and traces into the animation windows. Text can be displayed in a separate animation and formatted in a tabular form to provide a performance overview, or they can be visualized alongside the subject animation to provide a quick metric to aid the participants' engagement or as a means for quality checking performance. Let's continue with our max right knee flexion example and create a text that displays within the existing animation window. Right-click and add a text. Selecting Text 1 brings up a Parameters panel where we can set up this text. The name of the text, the Boolean condition when the text is visible, the font height and points, location, color, and text content can be entered with a formula. First, we'll enter the text content and then focus on formatting. The text content formula needs to be a string variable type, so we will need to put the text we want in between quotation marks. If we want to add in the value for our scalar max right knee flexion variable, we can use the string operator. Right-click and insert an operator and navigate to the string operators. This string operator takes a scalar variable x and the number of decimal places can be specified. Since we already defined max right knee flexion, we can simply right-click and insert this variable. We will choose to display 3 decimal places in this example. To concatenate this variable and the surrounding text, we will add in a plus sign before and after. Lastly, we can add in our units inside quotation marks. Now we can see that text was added to the animation window in the top left corner at location 0, 0. We can update the XY coordinates to center the text better in the animation window. Note, the size of the animation will determine the final layout of the text, so try and have the animation window size set in advance. Traces can be used to visualize the movement of the body during different activities. In this example, let's add a trace to the sacrum. Right-click and add a trace. Selecting the trace 1 brings up a parameter panel where we can set up this trace. Under position, we can define what we want traced. In this case, we will define the sacrum position by selecting subject 1, segments, sacrum, COM, position. Next, we can set the diameter of the trace in meters. Generally, a diameter of around 5 millimeters provides satisfactory results. The coverage indicates the portion of a time interval to be covered with the trace, and the number of selections indicates the total length of the trace. We can update the number of selections to 1000 for a longer trace in this example. Lastly, we can choose a color for this trace. Let's watch as the trace appears as our subject moves through the space. Traces can also be added to any objects as well. We mentioned a few Boolean statements in these last few visualization examples, so we'll now talk more about those. You might recall that the Gait activity has a few Boolean examples already defined with the right stance events. Looking at the right stance variable, it uses a force threshold to define the right stance phase. Right heel strike and right toe off are examples of nestled Boolean statements. Nestled Boolean statements require all parts of the defining statement to be true for the true condition to be met. So, in the case of right heel strike, if right stance is true, and at time 1 frame before right stance is false, then our right heel strike condition is met. In this activity, that condition occurs only once, giving us an instantaneous right heel strike event. Similarly, for right toe off, if right stance is true, and at time 1 frame after right stance is false, then our toe-off condition is met. We can then use these events to define periods of interest. These events could be used in other calculations, such as in the max operator example, to specify a smaller region of interest, or could be used to define events for data reduction, which I will talk about in an upcoming section. In the previous sections, we have covered defining your data metrics and analysis variables and visualizing them in graphs and animations. In this section, we can discuss how to export this data in a report. To add a report, navigate to the Reports node in the Analysis tab of the Components window. Right-click on Reports and add a report. If you expand the Reports node and click on Report 1, that will bring up the Reports Parameters panel below. Here you can edit the report name and specify the file format. The MotionMonitor xGen supports exporting to .txt files, which are any flat ASCII files and can be opened in Excel or MATLAB, as well as JSON file types, which are typically used in athlete or patient management systems. Either can be saved locally or streamed to an IP address for web-based applications or other customized solutions. or to be configured to be sent to athlete management systems like Smartabase. The MotionMonitor can be configured to export C3D files as well, but that requires an additional module. You can choose to include a header at the top of the report and to export in the frequency domain. You can also specify the sampling interval, or the rate at which data is exported at, in milliseconds. Data can be exported as single values or columns. Single values will appear above columns as one single value that remains the same throughout the activity. This could be your maximums, minimums, timestamps, etc. For example, let's add max right knee flexion as a single value. You can add single values similarly to how you could add analysis variables by clicking Add Single Value, right-clicking and adding a single value, or by copying and pasting an existing analysis variable. Since we already defined this variable under analysis variables, as is best practice, let's use the copy and paste option. Columns appear below the single values, and they represent time series data. These could be variables like kinematics or force data. With both single values and columns, you can copy and paste multiple variables at a time. For example, let's add our right knee kinematics variables as columns. The order of these variables from top to bottom will appear as columns from left to right in the report. Now that we have set up our single values and columns, we can generate our report by clicking the Generate button. When generating a report within this activity, it will only export a report for this specific activity file. We will walk through batch processing in a moment. The report we have generated is saved in a default location on the C drive. Let's have a look. We'll start by opening a File Explorer. To get to our report, we will go to the C drive, Program Data, Insport, TMM xGen, MotionMonitor, User. Now we will select the user of interest. In this case, we are in the Sample Scholastic Files User. And finally, Export. Here we can see our recently exported report with the name of the activity and report. Since we exported as a .txt file, we can open this report in Excel. At the top is the header we selected that includes the user ID, the date it was exported, the activity name and the date it was recorded, sampling rate, and the data capture period. Below is the single value we added, and then the columns we specified below. You might like to take a screenshot or video capture of the activity so you can share in a presentation, provide alongside a report to a participant, or within a publication. You can easily do this within the MotionMonitor xGen software. You can find the settings for these under the File menu, Edit Screen Capture Parameters. Screen captures will record a video and screenshots will take a snip of the specified capture region. The desktop option includes the entire screen. The main window includes everything visible in the MotionMonitor xGen window. The child window allows you to specify one of the individual windows in the MotionMonitor xGen, such as the animation window or any graphs. Lastly, if taking a screen capture, you can specify the frame rate below. When you are ready to take a screen recording or screenshot, you can navigate back to the File menu. If taking a screen recording, begin session capture, play through the activity as desired, and click End Session Capture to finish. If taking a screenshot, simply click Take Screenshot. Screen captures and screenshots will appear in the Screen Captures folder back in the File Explorer. For those who are more advanced users, you may also wish to write scripts that automatically take screen snips at specified time events, apply analyses, and generate reports. This is all possible within the software using our built-in functions. For those who might not have the time to figure these out, we also have some predefined analyses for certain sports, functional movements, and we would be happy to provide a service and to discuss options for custom workspace and analysis. Once you have finished defining your analysis variables, displaying any graphs, and have set up a report as desired, you can save all these settings as an analysis to apply onto the workspace or other activities. This makes the analysis process much more efficient, as you are essentially saving a template of your variables, graphs, reports, etc. There's no limit to the number of graphs and variables defined in an analysis, but the more that there are can affect loading and processing time. This becomes more important when recording data, so it may be helpful to note that analyses can always be applied after data collection. Some items are found within the Setup node, but are actually saved within an analysis because they are likely to be changed after data collection. These include hardware filters such as Butterworth, Chebyshev, Fast Fourier transformation, high, low pass, and notch filters, gap repair, force plate thresholds, subject-related data such as maximum foot to GRF distance and foot to force plate assignment method, and anthropometric data. To save an analysis, click on the Analyze menu at the top and click Save Analysis As. You will give it a name such as Gait Analysis, and click Save. The analysis file will be saved under Analyses in the User folder. You may have noticed that there were some additional options under the Analyze menu. Let's take a look. We've just used the Save Analysis As feature to save a new analysis, and when we are ready to apply that analysis, the Open Analysis feature can be used either on an activity or a workspace. Merge Analysis can be used to merge an analysis file with the existing workspace, instead of just overwriting the workspace. The window layout features allow you to save a template of the software's window layout, for example, the sizing and positioning of the animation and graphs. I will walk through the Extract Trials feature in just a moment. Next, I would like to point out another useful feature similar to analyses that allows you to export one or more components, such as an analysis variable, graph, or report, from one workspace or activity and import them into another workspace or activity. These are called component sets. As an example, let's use our report. If we right-click on Report 1, we see an option for Export. Next, you will give it a name, and click Save. Back in the Live window, we can now import the component set. If we go to the File menu, we'll see an option called Import Component Set. Select the component set we just saved and click Open. Now, if we navigate to the Reports node, we'll find our Report 1. We can also apply our saved analysis to bring in all the other variables and graphs to this workspace. Under Analyze, we will go to Open Analysis and browse to our Gait analysis. Now we can see the graphs and analysis variables that we had created. This will look just a little different from the activity file because no data has been collected yet. Some users find it helpful to create a separate workspace for data collection and batch processing. Previously, when we were in the Gait activity, we generated a report for that single activity and we just applied an analysis to a single workspace. If you would like to apply an analysis and generate reports for more than one activity at a time, you can perform batch processing from the live window. In the report, you can now see a checkbox for an analysis file. Check this box and we can now browse to the Gait analysis file we just saved. You can also choose to have the analysis file include filter settings and spline fit settings. Now, if we go to generate the report, it will prompt us to select activity files. For this example, we will select the 3 Gait activities within the Sample Scholastic Files and click Open. You will see a dialog box that keeps you updated on the progress as each activity file is opened, the analysis is applied, and the reports are generated. We can now access those reports in the same export folder of the users folder. Another useful feature available in the MotionMonitor xGen software for data collected in repeated trials, like the Gait activities here, is data reduction. This provides the ability to normalize, ensemble average, and compute standard deviations for multiple activities. Ensembled average data can then be displayed in an activity or directly exported as a report. Let's take a look back at this in the live window. We will navigate to the Analyze menu at the top and find Data Reduction at the bottom. This brings up the data reduction parameters. These settings are saved within the workspace and analysis files. You can choose to apply an analysis file. The standard activity duration specifies the length of the resulting data reduction activity file. Data reductions can be performed over the whole activity or just on data between defined events like heel strike and toe off for Gait activities. You can also specify the event detection interval, the resolution at which the software looks for the start and stop events. The number of points to sample is the resolution of the data included in the data reduction. You can choose to display averages, standard deviations, constituent plots and values. You can also choose to automatically generate a report. Clicking OK will prompt you to select the activities you want to perform the data reduction on. Here we can select the 3 Gait activities. And click Open. In this data reduction, you can see the same graphs as before. Now they have data from all 3 activities along with the averages and standard deviations. If you zoom in on the graph, you can see that the bright, thick plots show the average and standard deviation data, and the data from each of the activities is displayed with the dotted discrete plots. You might have a series of movements, phases, or cyclical movements within one activity. We have made it easy to extract those subsections out. Under the Analyze menu, we will find Extract Trials, which brings up the trial extraction parameters. We can browse to our Gait analysis again. In this example, let's trim our Gait activities between heel strike and toe off. For the start event, we'll select right heel strike. For the stop event, we'll select right toe off. If our activity had video, we could choose to include video that would also be trimmed. We can also choose to generate a report for each trial. Clicking OK will prompt us to select the activities of interest, where we can select one or more of the Gait activities. Similar to the batch processing, a dialog box will keep you updated on the progress of the trial extraction. Now we can look at the new trimmed activities in the Activities folder. The trimmed activities will have the same base file name as the original activity, plus the iteration number it was able to extract. Back in the Live window, we'll open up the first trimmed activity for an example. Here we can see that now the activity begins with right heel strike and ends with right toe off. We've covered a lot in this training session, and we hope that you can look back on this video as a helpful resource as you begin using the MotionMonitor xGen. Along with this video, you can also find a complete list of the MotionMonitor resources on our website, www.themotionmonitor.com. Once in the MotionMonitor.com, you can navigate to the support page. Here, I'll point out a few additional resources for you. First, we have our manual and tutorial videos. The manual has a list of basic elements of the MotionMonitor xGen software, many of which were covered in this video. Something to note with the manual is down in Appendix A, we have a full list of our available operators and how to use them. This can be especially useful when defining more complicated variables or scripts. Appendix B talks about using vectors, and C contains our reference list. You may need to refer to these for your publications. Next, we'll look at the tutorial videos. These tutorial videos talk through some more basic features of the software along with steps to set up for data collection. Next, I'll point out our knowledge base. Here you will find a complete list of support guides that walk through how to set up all the hardware we support, as well as different features of the software. Something to note is that our knowledge base is also searchable. We hope you find this analysis overview beneficial as you begin training on and using the MotionMonitor xGen for your projects. We look forward to working with you soon. If your system is on an active support program, you can schedule your annual hardware refresher training if you haven't already. If you're not sure about your system status, please reach out to us and we can discuss your training plan. As always, if you have any questions that you could not answer from these resources, please reach out to our client support engineers and email support@themotionmonitor.com.